So he works at University of Washington as a professor, but on the side, he's got one, maybe two, maybe more companies. It sounds like last time I talked to him a few years ago about this was he was doing Namatod, which is I'm sure one of the companies you hear about today. And it looks like the new company is called Tempo. Is that right?
That's right.
Okay. So Matt's a jack of all trades. He's worked at Intel for I don't know 15, 20 years. He worked at Intel, I think. So Intel, so he's done corporate, he's done being a faculty, a professor, and now he's done multiple startup companies. So I thought it'd be really interesting for him to come and talk to you today. So with that, Matt, take away.
Thanks, Kirk. Well, I guess we'll skip this one. Kirk gave some of the background, but let me give you a few more. Educationally, I've actually been here most of my time. Just up the road in Maryland in College Park, I did undergrad. I did a master's at UW, and then I met this guy right when he was coming to tech and spent some time down there. But that's not all I've done. Just to make it super crazy, I used to be a professional figure skater. I skated with Escapades and Disney for a while and toured the country. It's usually more impressive on the West Coast to talk about places on the East Coast, but I spent 5 years at the Pentagon doing some stuff, and then just over 15 at Intel. I worked in the server division. I designed CPUs and chipsets and large-scale server systems, and part of the reason that I met Kirk is his interest in HPC stuff, aligned with some of the things that I was doing. I spent some other time across the river at the Naval Research Lab in the Plasma Physics Division. So it's kind of fun to see the big domes over there again from the other side of the river. I spent some time working with a startup out of Tel Aviv that I'll talk about a little bit, doing some machine learning stuff before AI was technically cool, and ended up helping set up the US operations for that company. And then I've got two companies now. One called Namatod that Kirk mentioned, and I'll talk about in more detail. And then the most recent one actually started from building holographic signage, and has evolved into something else that I'll tell you about. So that's all the professional stuff. Some things you got to know, though. I get really bored and tend to do other things. So I really, really like to jump out of things. So jumping off of bridges, that's pretty fun. Jumping out of planes, that's even better. If you can't jump out of the plane, then maybe you should fly it. And then I don't know, I've got a Top Gun thing. And so you got to have a motorcycle if you're a Top Gun fan. So, but I also have been a volunteer ski patroller. Although honestly, I always try to stay away from the bloody end. So I just really like to ski. So what I wanted to talk to you today is contrasting some things from my experiences in the corporate world versus startups. So spent a lot of time working for the DoD, and then of course Intel, and as well as doing a bunch of consulting with large corporations. And there's really a key difference between how engineering works in those two different environments, right? So in a structured or a corporate environment, most of the time problems are fairly well defined. And you don't really, it's actually kind of an extension of being at university, right? Like they give you a problem to do. Here's your challenge to do. Here's your homework, right? And all you have to do really is figure out how to do that, right? That doesn't change and go to a major corporation. Usually they're defined, it's actually, building on the work of a whole bunch of people, some of whom are not technical at all, deciding what should be built, right? And maybe even some of those key features that should be built. Constraints are known. Usually it's budget, it's time, sometimes in many cases it's space or maybe it's power, but they're fairly well defined as well. And those requirements don't tend to change. So things tend to be very stable. So what that means is success just means you have to deliver what has to be done. That's not the case at startups, okay? Problems are not defined. Usually they're completely unclear. Maybe you have some idea, but they change all the time. So your requirements, are constantly changing. Your constraints change over time. I've had them change literally overnight sometimes. Okay, so the engineering you have to do is fundamentally different. Like the core mechanics of it are the same, but everything else around it is different. All right, and constantly changing. So success in that case just doesn't mean you deliver the thing, right, that was already predefined. Is it useful, right, to solve whatever the problem is that you're specifically, going after? And here's what I really want you to remember, from a startup perspective. What actually matters, at startups? Pain points. That's what you're after. If you want to start your own company, you want to run your own company, you've got to find whatever those pain points are first. What is that problem? The problems are usually easy to find, and sometimes people will tell you those problems, what they think their problems are, but they aren't at all. All right, is it real? Is it urgent? Is it worth solving? Is it something that's going to change how somebody works, acts, plays, or lives, every week? You need to have a champion. You have to have somebody who cares and will help drive that forward in some way. Okay, you have to have somebody. You got to win over somebody. It doesn't matter who it is, but it has to be you have to have a champion. With the champion, then you can help getting buy-in, right? And by buy-in, I mean like people who actually want to use that, support it, and most importantly, pay for it. All right. We're not doing all this stuff for free. Philanthropy is great, and that can be on the side. But in many cases, we got to get somebody to pay for it. All right. Your team. You're going to start a company. You've got to have the right team. I'm sure everybody has some war stories of people who they don't want to work with. They know exactly who they don't want to work with. All right. And for a whole, myriad reasons. Right. But the team is absolutely critical. In fact, this can kill everything. So you gotta manage that very, very closely. And you notice what the last thing on the list is at the bottom of the funnel? It's the tech. We always think that tech companies start with tech. And if you do that, you're usually doing it wrong. Okay, so tech, can we build it? Can we build it reliably? Can we build it safely? Can we build it at a cost that actually makes sense? Okay, these are the things that actually matter when you're starting a company. All right, and matter at startups from an engineering perspective. And why is this not moving forward? Click, click, click. There we go. Okay, so I want you to keep those things in mind, and we'll talk about that across 3 different startups, 3 different companies. Okay, the first one was a company. This is the Israeli company. It was called Parallel Machines. I think they shortened it later after I left to Parallel M. And this was a scalable machine learning platform. This was about 2015. It was exciting enough that I actually left Intel to go work with these guys. I was not an actual founder at this one. It was a couple of Israeli founders and really successful ones. So I think the key founder, primary founder, was a guy who just sold a company to TI. He'd sold another one to Apple. And this was the big data era. So consequently, training large models was difficult at the time. And so we built a scalable machine learning platform that ran underneath R so that you didn't have to change what you were doing from a data science perspective and use different scripts in which you already had with R, right? You didn't have to go learn Python. You didn't have to go do anything else. You just use R. And what was really good about it was this addressed some real technical challenges. It was difficult. In fact, we built a custom cluster to be able to do it. And then all of the system software on top of it that plugged directly into R that made R just seamlessly scale across hundreds or thousands of nodes in a cluster. I love that picture because it's so much fun to walk along that beach. Probably not now, but at least back then, about 10 years ago. So what were good things about this one? Pain points? Yeah, it was clearly a pain point. Like we had an important problem we were dealing with. It was technically difficult. It hadn't been done quite in the same way that we had done it, but was critical. And we had the tech, right? We built it, and we're able to actually see our various models that we had to completely rewrite in many cases to scale across this cluster, as well as the system software to make that happen work. The downsides, we never actually had a true champion. Like you're solving a technical problem. It's a great example of solving a technical problem that actually is important, but we didn't have a champion that could push that forward. Lots of possibilities. We were working with Cray, we were working with IBM, we were working with, of course, Intel, HP. I know Intel's kind of a bad word these days, but we didn't have anybody that was willing to buy it. Okay, if you don't have somebody willing to buy it, then you don't actually have a product. And then kind of in a light, I guess that's a pink or an orange, was team. And I'll tell you, we scaled up really, really fast. Offices in Boston, Tacoma, or Seattle, and Santa Clara, and ended up making some hires that were not interesting. They were difficult to work with. Okay, in fact, that's actually why I left. It's like, okay, it's clear that we don't have something that somebody wants to buy. Arguments amongst your team about how to transition that or pivot it, and it didn't work. So it ended. How did it end? It ended in a fire sale. It actually got bought by another company called Data Robot, and they are still going, but an absolute fire sale. So for a company that raised $30 million in a Series A, has flush with cash, this is a terrible result. Okay? In this case, the problem was real. We didn't have a customer, and we didn't have anybody paying. Does that make sense? Fast forward a little bit. So my second startup, this one was mine, I should say is mine, very different. At the time, I had done all this machine learning work and scaling work, and gotten away from building hardware directly, and I was actually started at the University of Washington, and in setting up my research lab there, started hiding devices all through the building. Now don't do this, because somebody will find them. They found me. And all I was doing is trying to collect data about what was going on in the building, right? And then tried to find a problem, because a lot of times in academia, you can do that. You can kind of wander around a little bit and try to figure out a problem to work on. And so that's what I was doing. I ended up having a conversation with somebody in economic development and a fire chief of all people, and talking to them about how could we use this to predict occupancy in buildings so that they could expedite response operations, right? So large buildings at the University of Washington, lots of rooms, lots of labs. How do they know where to go, right? And he said okay, that's interesting, but I don't think we can do anything with that. All right. And here's what I did. I just asked him a question. I was like, what keeps you up at night? And that one question led to him saying, listen, what I worry about is sending a whole bunch of people into a building to go respond to somebody or for a fire or smoke, whatever, and they get injured or lost and they can't find their way out. I have to go rescue them. It's called a Mayday scenario. And this had happened to this guy, Brett Tarver, I think a couple of years before, where they were responding to I think it was a Safeway fire or a grocery store fire, and he wasn't caught anything. He was just disoriented. And it's dark, lots of smoke, and he couldn't figure out his way out. He ended up dying. And so he's like, this is what keeps me up at night. And of course, being naive, I was like, okay, I bet we can fix that. And it turns out that that's a really, really difficult problem. Okay, but we got a clear pain point. Pain point here is death, right? So I don't think it gets much better than that. Certainly better than trying to make something more efficient. And so, hey, but how don't we try to keep somebody alive, right? So our pain point here was, situational awareness challenges. How can we introduce some tech or some capability to enable people to navigate dangerous or unknown spaces, right? And particularly spaces where your GPS or your phone just doesn't work very well, right? In many cases, you're outside the building, so it doesn't really matter. But as soon as you go into that building, sometimes that becomes difficult, okay? And want to be able to provide that kind of situational awareness. This isn't new. This is like what you watch on Mission Impossible. It's Tom Cruise going to some crazy things, and you see a blippy on a map, right? They want that for real because it doesn't exist, right? Or it doesn't exist for those situations. And so in those cases, not having enough information about what to do can lead to serious injury or death. Well, that's cool. That's a great pain point. And that's what we set out to try to solve with the Nomatod. So the Nomatod, we do. I'm not going to read this to you, but it says first responders and war fighters, and I'll tell about that pivot here in just a second. But the idea is to provide real-time location visibility, for people responding in places where they can't have access to cell signals or GPS, but still make their location visibility apparent to those that are going to go rescue them or that have to monitor their protection. Okay, so we built this system called Firefly. There's a whole bunch of different variants of it, depending on what it's being applied to. It's really just three main chunks. If you want to think of a funky cake diagram, right? We built wearable devices that went on every individual that would, form its own mesh network or be connected in some other way to a network that would stream data to a live server that was on scene, because we couldn't count on cell connectivity, and then we'd have some way to be able to visualize where everybody is. Okay, so we ended up integrating environmental sensing and monitoring into that as well through some additional devices. But the idea was to be able to put all this stuff on a map, kind of very Mission Impossible-like. And that's exactly what we did. So this, if it works, should show you, give you some idea on how we originally designed this system. So somebody goes into this complex building, tries to find somebody. As they went in, I think it would drop, they would leave some other kind of breadcrumbs that don't show up properly in this animation, clearly, since it's quite old, but would provide that connectivity all the way through this complex building and be able to tell us exactly where they are from the outside. We did later integrate drones into it, if it ever shows up. What do I have to do? So one of the things firefighters do when they respond to a large building is they actually go around the entire building, so they have some idea on what's there. They call it Alpha Bravo Charlie Delta sides that also establish additional communications if the building is quite large, like it would be for this one. In addition to that, we built autonomous drones that could be flown around by themselves to position themselves in different places so that we can maintain that connectivity, as well as a drone that could fly around the space so that, if there were chemicals or contaminants that were being released that were harmful to on-scene personnel and or the surrounding area, we could record what that looked like and have that in real time as well, rather than going, I don't know, the smoke is black or it's red or whatever it is, right? I think it might be that. We would actually know. So we built this. And, the amazing thing in terms of as I'm talking about the different points, the things you have to have is a champion. Well, it's actually really easy to get fire departments to champion this, right? Because it was literally for them, right? So we had this amazing agreements in place and engagement from various fire departments around the country. And what was really cool is we got to burn down a lot of houses. And so it's not just, it set off some fires just to be able to test some things, but I don't know if you know this, but occasionally if a house is going to be torn down anyway, you can, I guess, donate it or something to the fire department, still maintain your property, but they'll burn it down for you. And they use those as training events. So every time there was a training event around, we would attend. And we would actually outfit all of those firefighters with those devices, with our devices and our systems, so that that incident commander could keep track of everybody. Okay, this middle picture in the bottom is actually a real-time image showing what it looked like in terms of like a heat map of contaminants around or over the house as that fire was burning, kind of showing how we were seeing different contaminants, through some color mapping while it was burning. It's an early version, so it's not great, but you get some idea on what it was doing. Once you get invited to one house fire, you get invited to a lot of house fires. And so, again, amazing alignment. So this was a house they were burning down in a different part of the state that they were going to build a high school on. And we went and did the exact same thing, but now we got to do other tests, right? And evaluate how they were operating. Of course, you got to have the selfie picture in front of a house fire. That's just cool. But on the right, you see some examples of where all the personnel were as they were doing their training scenarios, right? So this, this was great. So we're a field tested system. This takes us, we know it works. We know it'll work with them. Through this process, we actually had to, iterate the design multiple times based on their input and feedback. And then it came time to sell it. And that's where things got a little difficult, all right? It's easy to do demos, but as soon as you want to transition them into paying customers, that is often a different issue. And here's what we realized is we built a Ferrari. We built something that can handle like 99% of the cases where it could be deployed. We made it so it was completely offline. It didn't rely on cell coverage, right? We made it so that you didn't have to bring a network. You just had to bring our system. We built a full Ferrari. But a lot of times, people just want to pay for a Honda Civic, okay? So that caused us to shift things a little bit. And in fact, we realized as the market needed a Honda Civic, it didn't need a Ferrari. Now they want a Ferrari. Who doesn't want a Ferrari? It's Italian. So so we shifted a little bit. In fact, we almost ended that company. And then I found this program called the CIBER program that the government provides. Particularly, I think they're required to allocate a certain percentage of the budget for small businesses to do these kinds of grants if their budget's over a certain size. And of course, the DoD, has this. And right about the time that I was about to consider hanging it up because I couldn't get anybody to pay, I found a grant call from the DoD, specifically from the Army, that was very vague. But it was PNT. PNT's position, navigation, and timing, right? And it was almost like it was written for us, right? So in true style, I pounded out a proposal for this in 24 hours because the deadline was the next day, and submitted it and won. Phase one, just to give you some idea, phase ones are usually about a 10% acceptance rate, so they're typically difficult to get. Phase two is usually higher because they've already pared everybody down. So this gave us, some money to investigate the feasibility of adapting our system for what we thought was just Army people, right? We didn't even know who they were. And the only information we had was literally about 3 sentences that was written in the public profile. But what we later found out, this was actually for special forces. So it's for US SOCOM, which is what that insignia is on the right. So just like we did before, we first have to understand, what's the pain point? Well, what if you don't know? What if you can't get it out of them, right? This was in the middle of COVID. This was right when everything got locked down in 2020, and I was fortunately able to keep my access to the university because they locked everybody out, even faculty and staff. I was able to keep it because we were 3D printing face masks for all the first responders up at the UW hospital. So I kept it. We did all of this work in the middle of COVID, but because those guys were not responding to anything either, we didn't really know what they wanted, right? We just had those 3 sentences. So as soon as we could, we went to them. So the importance here of fieldwork is, I cannot stress it enough. You can build all these things in your own mind, thinking you understand what that problem is, but you actually don't. So we flew to North Carolina. After a bunch of calls, we thought for sure we know exactly what they want. We're going to go demonstrate it to them. We're going to go have beers afterwards. It's going to be awesome. And that did not happen. We went there. We demonstrated what they thought, what we understood that they wanted. And it wasn't that at all. We built probably 10% of what they wanted, but they didn't describe it in the way that we understood. Or maybe we didn't reflect it back well enough. It's not exactly clear. But being in that room with them, for 2 days gave us that insight. And they said, hey, okay, now that you understand what what we actually need, I want you to come to Fort Bragg in North Carolina in 7 weeks, effectively next month, and demonstrate it. And what we didn't know at the time was that when we were demonstrating this, we were demonstrating at the end of the week when the company that they'd been working with for the prior 3 years was there in the beginning of the week, and they were holding a bake-off, and we didn't know it. But we did it. This is the urban warfare training range, range 68 out at Fort Bragg. And before then, we did a lot of work. You see Tatiana on the upper right there. We taped all kinds of devices onto her so that we could test this stuff in our office before we went, hoping that we'd hit all the points. We went there, we did it, we did demonstrate it, and it didn't work quite the way they wanted because they had these super high power radios on them, that were basically blocking most of, or a lot of our signals, right, for communication. So it was working, but we couldn't show them that it was working. And so after talking to them for a while, and actually they were trying to get us to fly more devices out to ourselves because we left them at some other ones at home. I said, whoa, hold on a second. We're gonna go work on this tonight. Let's meet up tomorrow morning and we'll see what happens. And what we ended up doing was, this is an Airbnb that fortunately had a nice outdoor kitchen. We set up out there, we worked all night, and I think we finally stopped working around 4:30, 5 a.m. Got in the car at 7, went back out to the range, and then demonstrated it working in the alternative way. And you know what they took away from that? Yes, they were impressed. They were absolutely shocked that we made all the changes we talked about. And they said, you know what? You guys work at the same speed we do. You work at the same operational tempo. We're going to work with you. And we won that bake-off and then won a bunch of contracts. So that other company, everything that other company had, all the funds that had been allocated to the other company, as well as all the equipment, got reallocated to us. Okay, the key pivot on this one was understanding that they weren't actually looking for blippies on a map. In fact, they didn't even want a map at all. All they really wanted was location accountability, right? So they understood this problem well enough that they knew that it couldn't have a device on the floor because RF propagation wasn't going to work that way, right? It wasn't going to give you the signals that we wanted. They just wanted to know where people were relative to what they called phase lines, or were effectively checkpoints, right? And they also they didn't want our integrated mesh networking. They wanted us to integrate with their own radio systems. These radios are like 25 grand each, right? And so they're like, we've got our own radios, we want you to work with our radios. So we had to go do a redesign to be able to interact with those directly through a wired connection instead of wireless because they didn't want that. But all of these things happened, having worked with those customers. Now, there's some question of how much technical stuff to go into. But here's a little quick sampling of all the things that went into this, okay? We went through, I can tell you all the ways not to build this, and in fact, I won't tell you how to build it because that's mine. But all the things you had to know in order to be able to build something like this in a form factor that's small enough to work this way. For location accountability, you can go Google some stuff. In fact, you can go to some GitHubs and get some initial code to work with, even probably some hardware designs to work with. But I can tell you it's not enough. You have to combine all of these things together. So we did lateration, we did trilateration for 2D, we did multilateration for 3D. We integrated some curve fitting stuff as alternative algorithms to see if that would work. That was Levenberg-Marquardt. We integrated pedestrian dead reckoning, which is terrible because of drift, but is useful in some cases to be able to fill some gaps or interpolate. We had to integrate some digital signal processing for some of the filters, right? But then we had to tune those filters over and over again. We integrate sensor fusion to be able to combine all this stuff together. We actually reverted all the way back to triangulation to solve a specific problem that didn't need the full solution. It needed to be faster, okay? And then when we had about 5, 6 different ways of doing all these things, we integrated another capability to do real-time parallel alternative selection of potential positions, right? And then combine that with fusion to do an error estimation to be able to figure out which one to use. This is all operating on a device of this size. And this is actually a big one, because it has 3 microcontrollers and 3 different transceivers, okay? That has to be able to be thrown across the room. That's always fun.
Oh, it came apart.
I didn't have the top on it. Has to be able to thrown across the room, be water resistant and simple to use. You're using gloves, That's why you can just pull the pin like a grenade. It's not a grenade, but you can just pull the pin to activate it. Okay. It has to be in an enclosure that's able to take quite a bit of heat. All right. It's got to be able to be run over. These guys are rough on things. So what did we do? We threw them off buildings and then iterated the design just on the enclosure itself. We ran it over with my car a lot, right? Over and over again. See if you could actually drift on it, to see if you could, make it come apart. And then we had to design custom hardware. And I'll tell you, we went through about 4 different hardware designs. One that we actually took through full FCC testing. So I can tell you what it looks like to go through an anechoic chamber, and I can tell you how much you cry after you don't pass. But I can also tell you how much you can celebrate when you do. And then alternatives. And I remember we built this really elegant one that was a full board with these little daughter boards that socketed on. So we could have 6 microcontrollers on one unit, and we could scale it as we needed to. And they looked at it and were like, that's too big. Okay, throw it away. Try again. Okay, so all of this stuff, we integrated all this stuff into custom L2 protocols that exist on our ultra-wideband transceivers, as well as our other transceivers. From the system perspective, we had to make sure that we had low latency, real-time messaging capability. We could monitor what the situation was with every given device. We had to be able to generate alerts when somebody fell down or when they were offline for so long, or even have the capability to be able to monitor their air tank to be able to tell when they needed to come out. And then we had to make sure that our network was interoperable across their own networks, right, and their own devices that we knew almost nothing about. Just to give you some idea on what that looks like, okay? Seems like a small little device, but there's a lot on there. What does that tech look like in practice? On the left, you can see our little tray we used for being able to test some of these devices. These are older enclosures. So I can tell you that these particular enclosures will in fact melt because we melted a lot of them. But what we use for testing and setup, on the bottom, in the middle left there, you can see one of those radios we had to be able to connect to. And we had to be able to, as simple as just plugging in a USB cable, right? And suddenly it would work. We built a custom Pelican case that acted like, again, kind of go back to the Mission Impossible stuff, right? You get to a scene, you pop open the thing, and all of a sudden you can see everybody. We built that. And then the right picture and the top picture is actually deployed in real practice. So that's actually an ATV that they use for some of their operations. And that's a real 47 that only landed with the rear wheels when they deployed with all of our stuff. I said you have to have a good team. This team is so important. Okay, we've gone through some people. There's some core people. I like small teams before the issues start. It's like when I teach senior design. I always tell people, okay, you can have 3 to 5 people per team, but you should pick 3. Because there's always going to be a pizza guy, and then somebody's not doing anything, right? In our case, we had 4. Okay, 4 of us. We had some others as well that were not always there when we went on scene. But this is very different work. You can see we're doing highly technical work, to design and build both these devices, the firmware and the overall system. But then it was kind of fun to go hang out on tanks and helicopters and deep into tunnels. I think that one was we were about 2 miles deep in that one. And you got to have some silly time where we light everything up in testing. That upper right picture is literally an Airbnb where we needed to test all the devices before it got deployed. And it was simplest to take off the Velcro, attach it to the couch, and move the couch back and forth across the yard. But it was fun to take a picture when the lights were out. Okay, so the team is critical, and I can't tell you how amazing almost everybody on this slide actually is. There's just one that I had to deal with. Champions. I intentionally left this zoomed out, but these are some of our champions. This was taken after a practice exercise at the Edgar mine in Colorado with the actual customers that were really using this. So that's all of our SOCOM story. There's more to it, but just to give you some idea on some of those critical things for or some of the tech involved in that. And while we did that, we parked everything we did with fire. Remember, this all started with fire, right? And so we parked all of that work and engaging with fire departments because honestly, this work with SOCOM was so critical and time sensitive, and there was a lot of money involved, that we parked all the firework. And we eventually came back to that. This kind of comes back to that original observation. We built a Ferrari. And organizations like SOCOM need a Ferrari, right? They don't want the Toyota Camry, the Honda Civic, and nothing against those. But what fire really needed was a Honda Civic. And so more recently, we actually have gone back and started building that Honda Civic. What if we relax, that 19% of the problems that we were trying to overcome and get us back to an 80% acceptance, right? So now we have a centralized controller where it's just using their phones. You don't need other hardware if you don't want it. But we put the phone in the center of the system on the individual and enabled all our devices to be able to be connected to that phone, assuming that that'll serve as the backplane. And we pushed all of the analytics, all of the messaging, all of the data storage, all the coordination, all the map generation, that was in our on-prem server that you would have to have in that Pelican box to make the system work, and push that into the cloud. And for them, that's good enough in most cases, right? Particularly when they're not, for departments that aren't doing a lot of aggressive, or I should say offensive operations. They're doing defensive operations. So we're adapting to these needs, taking into consideration the constraint of what funding is available. So this one, I think we got most things right. And why is this company still going? We addressed those major pain points. We identified what they were. We found champions at each one of them. We got them to pay. We got a good team, and the tech is unreal. In fact, Lincoln Lab did a study on behalf of SOCOM last year, and trying to find alternatives, and there aren't any. Startup 3. This is more recent. So when you're working in government contracting, sometimes the government has some operational issues, which then can affect funding. And so to try to counter that, or to be cognizant of that, I had a friend that was operating in was effectively, they were trying to operate as an ad agency. They weren't really, but they were close. And so I got interested in ad tech, and this is a completely different space, but this is what led to the company that I now call Tempo. So I'm not going to go over this in much detail, but just to give you some idea, I had no idea how this space worked. I had maybe just a little bit from working with some companies at Intel before, but I didn't really understand. But this gives you a kind of an idea of the full programmatic advertising pipeline, right? So on the far right would be your websites and your apps that actually are trying to generate revenue by displaying ads, and they give you the spaces that are available. Those are usually then sent, the availability of that space is sent to an ad network, which goes to a supply-side platform, who basically brokers that for you, and they try to sell it for you. And so on the other side is a demand-side platform, so you can think of them as operating on behalf of the a brand or an agency that's trying to send out ads, and they hold an auction and try to figure out the best price to be able to display those ads. This happens really, really fast every time you open a browser or an app that's supported by ads. Okay, so all of this is happening, and what's interesting about this, or what I found interesting about this, is that there is a cost for every stage of this pipeline. So if you spend $1 on advertising as a brand or an agency, only about 10 or 15 cents of that dollar make it all the way to the website. Everything in between gets absorbed or and expensed by every one of these steps along the way. Well, that's interesting, right? So that tells you that there's probably 85 cents on the dollar for any ad spent. And anybody know how much money was spent on ads in the past couple of years? It's close to the DoD budget. It's ridiculously large, right? So of course I saw this and was like, that's interesting. Okay, so what could we do there? So this company, I did some consulting work for this other company, and figured out that actually we can bypass a good bit of this. And I set that up for them, and then as I started learning more, realized that out of the home advertising, those billboards and things you see on the metro or other signs and stuff isn't included in that at all, right? And as part of that, there is there's almost zero attribution. So when you click on an ad, somebody gets paid for that, right? So they get paid for every 1,000, but that's why the CPM is, right? Cost per mil. But for out of the home, that doesn't happen at all. In fact, most of it isn't digital at all. So if you want to be able to, send something to a digital billboard, even though it is digital, it's difficult. And on top of that, you can't tell who saw it. So if you are charging for rendering those ads based on how many people saw it, which is how programmatic advertising works on your apps or your websites, you can't do that in out of the home, right? Largely because it's attribution. And in fact, you know what they do for actual attribution? Geometry. They literally go, where's the sign? How far is the roadway? What time of day? And they estimate how many people are going by. Are you actually reaching the people you want to? You have no idea, but you're going to pay for it. So that got me really interested. And I had a friend that was going through Hartsfield, the airport in Atlanta, and he went through security, and they had all these little gun things like floating in the air, telling you not to bring weapons and such. And they were holographic fans. I mean, they've been around for like 15 years, right? But all they are is holographic signs. It's nothing more than a fan that spins really fast with LEDs on it, timed just right so that it looks like images. And it's really cool because it looks like it's floating, right? And so thought, you know what? That's catchier. Like, look how many screens we have. Don't have any fans. So let's do that. Let's sell these, right? In fact, let's hook these into programmatic advertising so that we can be an SSP and be able to tap into that ad tax chain. And we'll fully digitize this in the process. It'll be a new medium. It's catchy. And in fact, I think we can actually measure attribution if we do it that way, rather than relying on these third parties that honestly are guessing. They're making up information. They're making up data. So, as an ECE guy, let's just build one. So I came up with a full holographic fan design in just a couple of weeks. We actually bought some. You can buy these on Amazon. They're pretty cheap. We disassembled them, realized, oh, geez, those are the same microcontrollers we're using. And it's just a bunch of LEDs. Okay, we just need a bunch of shift registers, or LED controllers to be able to do that really fast. And then we got to convert the images from Cartesian to polar coordinates and get the timing just right. So we did that. So we built a whole bunch of, we came up with a holographic sign design, created an entire BOM, passed it off to my parts supplier because I have one. And they're like, okay, it's going to be this much. Here's assembly because I have a contract manufacturer that assembles all my devices. And he's like, it's going to be this much. And these same size devices that I can buy for $150 on Amazon were going to cost me like $400. So what do you do then? Well, that doesn't really work with my business model. I'm trying to basically give these things away, right? What's your next best thing? Hack the existing ones. So reverse engineer the entire communication protocol that was talking to every fan, right? Because they had an app. You can get an app, and you can get an app for your laptop as well, and hack that protocol to figure out exactly how I could reverse engineer how they were talking to that fan. Hey, Val. Good. And so we transitioned from building our own signs, because remember, part of this is I haven't raised any money to do this. We've just been doing it ourselves, right? And so I really don't like a boss. And so I have a boss, but it's me, and it's just when I turn around. So we were doing this with zero investment capital, leveraging the money that we had previously made from the other company. and kind of ping-ponging these things back and forth. So we've got the tech. We've got alternative, cheaper tech because we hacked it. And now we just need some champions. So we took this out and we started deploying fans around town. We had them in the Tacoma Dome for a while at a whole bunch of different events. We sat there and measured, are people paying attention to our stuff? Are they looking at these stupid TVs? The answer was by 800%, they were watching our stuff. And then we were able to build full heat maps across the entire space so we could see how many people actually saw this, as well as how they were transiting. And of course, we had some at some bars because, those are friends and they're easy to get to. Give you some idea, we started transitioning this over to doing it for schools, right? Like, can we deliver messages to the student population on campuses? I mean, can we use that to understand, how people are moving, around that campus, right? It kind of goes back to the original problem that led to me developing Nomaton. So this is a contrived example, but one we actually did. So the data is real, but on what the heat map showing what the population looked like, what the density of people looked like as they were moving about campus, going around our signs. So going back here, this set us up. Going back to this ad pipeline, this set us up on that right side, so we could own the entire right side. Well, that's at least 50% of that money. So, so we started deploying on campuses, and every time we talk to the Marcom people, Marcom people are the marketing and communications people. They're the ones who spend all the money trying to get you to come here. And we heard a couple different things. We heard that this is shiny, fun, and new, but it's not needed. It's not necessary. And so, some things we heard. I don't believe impressions or clicks, right? So even the reporting data they're getting back right now on ad campaigns, they don't believe, all right? The things that they're seeing happen on their site, so for campuses or for universities, it's how many people clicked on this department, right? How many people looked at the institute here, right? How many people actually clicked apply? How many people clicked to pay a deposit? All the interactions you have to do to join, the data they were getting from their ad campaigns didn't correlate with what they were seeing in terms of traffic on their sites. And so, and not only that, it's not like they're just sending out, billboard ads, right? They're sending stuff to the Google. They're sending it to Meta, so it appears on Facebook and Instagram feeds. Anybody see some stuff from the Institute appear on any of their feeds? TikTok, Meta? Yes? Yes?
Wait, can you repeat that feeds or?
Yeah, any of the channels that you, I don't know, whatever you go. This is what I do for the first hour when I wake up, right?
Yeah, it's just normally, I don't know, it's just human psychology. It just feels like it became like an addiction.
Yes, it is. It's a lovely addiction because it supports advertisers, it supports me. So consequently, it is a great addiction. But you saw some stuff for the Institute, right? Or tech or something. Did you see something? Nothing? Oh my God, okay, you can stay over there. But no, I'm just kidding. So they can't correlate any of that, let alone across different channels to what somebody actually does, right? So it means if I'm trying to bring in, 100 new students, right, or 100 new certificate students or whatever, and do I spend $10,000 over here or do I spend $10,000 over here? They don't actually know. Like a lot of that's gut reaction. It's based on what they've seen happen to work, at some prior campaign, but they can't actually tell. And what's more interesting, at least for some of the schools we've been talking to, UW, Loyola in LA, UPS in Tacoma, in order to get more money for their ad budgets, they've got to be able to justify it. How do you do that without data? You can't. Okay? So the key thing out of here is while we engineered a really cool solution that was shiny, provided more data, was honestly, it's pretty sexy. It's pretty cool. I can't tell you how many places we've been when the lights are off and you turn that thing on and then everybody comes over like mosquitoes. Like it's super cool. But you know what? It's a nice to have. It's not a need to have. And that's what you have to really look for. Is this a need to have? Okay. And the holographic signage was not. So we pivoted this one more time to what we're now calling Tempo Campus. And by the way, I own Tempo Signs, Tempo Ads, Tempo Campus, and even Tempo University as a demo vehicle. So I have my own university now. It's a .com, not a .edu, but that's where you make money. So we pivoted this over to Tempo Campus to be able to do that. We built some custom models to be able to take your marketing spend and then also be able to correlate that to whatever goals or objectives you're trying to hit. And you get to define what those look like, right? As an enrollment officer, as a Marcom, person. And then show you how your spend is actually translating to whatever your goals are, as well as predict alternative ways you could be doing that spend to achieve your actual goals. All right, this is actually just a screenshot of the demo page that's up live. We've been using to be able to show what that would look like for student applications, but that's just one goal, right? Just give you some idea of what that looks like over time. Again, this is cross-channel. So things you might run a meta campaign for 2 weeks, and then in the middle of that, you go, oh, wait a minute, I also want to run this Google, ad search for 3 weeks, or start adjusting things. And what this model does is actually show you how that spend is either efficient or inefficient, and how whether or not it's actually leading to what you're trying to achieve. And then we combine that with customized models that provide that direct attribution, right, for specific colleges or universities, right, across those omni-channel campaigns. All right. Now, what I didn't include here is there's a whole other approach that I just put a paper out for preprint that shows how you can do all of that, more generally with just publicly available data, right? And there's lots of places that do that, but they do it kind of piecemeal. Came up with a new index for that I call HEDC, and we're going to push that out to some Marcom venues soon, because it's just able to aggregate all of that at once, giving you an idea of the overall market. Right? And then customize it by institution. Go. Okay, there shouldn't be pricing on here, but that's okay. But it's really, right now we're providing these observability tools that enable that normalize the comparisons, right? So I'm getting data from Meta, I'm getting data from TikTok, I'm getting data from YouTube, et cetera, et cetera. Now we can see how that looks like normalized across all of them without each of those vendors then telling you, hey, actually, all your stuff's coming from us, all right? Because they will 100% lie to you, okay? We can help manage how, those which different media channels you should use, right? Based on what we actually see happening, okay? And we're completely unbiased. We don't really care. Like, this is your data, right? So we're just giving you an alternative way to do that. And on top of that, we integrate an AI agent to serve as an augmentation of, or to augment those Marcom teams, because in a lot of places, school budgets are going down, right? And layoffs are happening, right? There's been a big crunch on all universities. Christ, I saw some video recently. It's probably it wouldn't have been TikTok since I don't watch that, but it's probably one of those reels that showed somebody getting some degree from some college in Maine in like 3 months. And I'm like, okay, somebody's hacked into something. I don't know how they did that, but as a result of these kinds of things, we're seeing, enrollments go down. I don't know if that's the case here, but it certainly is on the West Coast. But the idea here is to be able to, as the number of Marcom personnel are contracting, we can help augment them with ways that they can, see this kind of information quickly and in real time. So for this third startup, pain points? Well, I think we pivoted around a lot. I didn't even tell you about the AR stuff we did. We're able to, generate ads on walls and stuff if you're wearing, Apple Vision Pro or some others as you're walking around. I thought that'd be an advertiser's dream, but I don't see anybody with those kinds of glasses on. So that wasn't realistic. But pain points, I think we finally figured out, some pain points where somebody will pay. right? Champions, yes, we have several, right? No East Coast ones yet, wink, wink, but we have several on the West Coast, and those are actually paying, right? So we've had a number of these kind of paid deployments. Team, now I really like small teams, all right? This is two of us. This is just two of us, all right? My friend Nate, who is mostly a stay-at-home dad, but an amazing sales guy, and you know, between he and I, we were able to handle most of this because we've automated all of the steps in the process as we've gone along. And the tech's the easy part. Particularly since we've alleviated a good bit of the hardware, we do make that available for things like campus tours, for enabling self-guided tours, be able to help people navigate around different large spaces or buildings. And the tech is all in place and live. Okay, now this has been an iteration, right? So I can't say this one's completely successful yet. Like I said, tempo signs, tempo ads, tempo signs, when we first started the holographic stuff, the idea there was we were gonna enable people, we're gonna give this hardware away, and then they were gonna make money on the ads that we render on there. That's still up and available, but don't send anything. Tempo ads was our whole DSP so that we could enable people to access all of those channels and run their campaign spend through us. And Tempo Campus is a more holistic solution to the everyday problem, not just, you know, the once in a while problem. So this is how I tend to look at things right now. It changes. You know, I was looking at the talk I gave here, well, I guess Blacksburg, you know, 3 years ago, and it's a little different, right? In keeping in mind that this isn't, so the message I want to leave you with is this isn't the field of dreams. You can't just build the tech and they'll come. You have to actually go make sure you're solving a real problem, and ideally a real problem that doesn't happen once every 3 years or is just shiny or fun. All right, those are great. Those are great. But if you want to have that recurring revenue, you know, where you don't need outside investment, you've got to address those key pain points, and it has to be before the tech. That has taken me a long time to figure out, and I still want to go build something right away. My friend and co-founder Nate, you know, I think it was the first time 2 weeks ago, he's like, "Yeah, you're pretty damn impulsive." I didn't realize how much so until we talked about one thing one day, and then 12 hours later, I was like, "Okay, I've got it. Like, here's how we solve that." And that's too fast. Sometimes you just got to slow down a little bit. Okay, a champion. You need a champion. You need somebody to advocate on your behalf, particularly if you're a small team. If you're at Microsoft or Google or Intel, don't go there. AMD, Micron, somewhere else, right? You know, you're going to have a whole team of people to help do those things, right? You don't necessarily need somebody to advocate on your behalf or to get that verbal confirmation that you're real, right? And stuff does work, right? You need somebody like that to advocate on your behalf. You need somebody that pays. It's okay to give some stuff away for free for a little bit. Gotta get them on that subscription, right? You gotta get them sliding that card or accepting invoices and paying them. All right, so that's what really matters. Will they pay for it? There is a term I can't tell you that this guy that I met at one of the SSPs told me that how can I say it in a nice way? He's like, everybody will sit in front of you and go, "Oh my God, that's amazing. Oh yeah, that's so cool. That's so cool." Yeah, I'm not gonna say it. Grin something. Grin effing you. That's what they're doing. They're just telling you what you want to hear. They're nodding and saying yes because they're gonna get away from you here shortly, and it means nothing. Okay? When they accept the invoice and say, "Hey, I'll buy that," that's when you know you got something. Okay? Team, don't forget your team. It's absolutely critical. Okay. We'll say we have, you know, had to get rid of some people. I've listened to some very spirited arguments for helping some people move on to their next positions on planes, and they were 100% right. Just do it fast. Just do it fast, okay? And tech, while it is super cool, in some cases is last, all right? Don't go build everything. I'm as guilty of this as anybody else. I will try to build everything, and you just can't. You don't need to. You need to get that feedback so that you're not on the 20% of that 80-20 split, okay? And Namatad, we were 100% on the 20%, or in the 20%, all right? And we needed to be on the 80%. You've got to be on the case where you've got most of the stuff, but not all of it, because there's always time to develop new stuff, and those can just be new features. Okay? Go, 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 go. You want to talk some more? I'm always available. Okay?
Questions in the room, maybe before I pick up the microphone. Well, you're going to watch the questions online, I think?
Yes, I have one.
Okay. So, you have one? Go ahead.
All right. Matthew, it's a great talk. Thank you. I have a question here from Paul. How did your education at Virginia Tech contribute to your journey?
How did
what was your education at Virginia Tech contribute to your, I guess he just said things.
Yeah.
contribute to all these things?
Yeah. Methodology. The question mentions your methodology specifically.
Oh, your methodology.
Well, this is one of the things I think is a little different. So the research methodology certainly plays into this, right? Like understanding what's going on in the space. You got to understand that right away. Like diving in, okay, where are the most important venues, right? Where am I going to find this information? Who's doing stuff? Because unlike the research side where like ideally you want to carve out some little niche, when I look at it from a product engineering perspective, I want somebody who've already done it, right? And I want them to have some market share, right? Because that tells me that we're onto a problem that actually matters, that people will pay for, right? Other things, the methodologies very, very similar, like the experimentation phase, evaluating results, knowing how to evaluate them, looking at them from different lenses, even from completely different market perspectives. I mean, sometimes you have to transition over to a business side, right, or an economics perspective. The guy that I just cited that I found that was closest to what I was doing with the higher education index stuff. There's another one. It's called HEDI, and I was like, that's really close to JEDI. That's kind of cool, but like. So I made another one that was HEDC, kind of trying to draft off of that, saying like, we're not completely different, but we're adding a bunch of stuff you didn't have and looking at it a different way. I don't think I would have done that in the past or before. I mean, you got to remember that was almost 20 years ago, but that was down in Blacksburg. But that same approach, applied, right? Like, let's go find out what other people have done, and let's see how we can build off of that, because they've done some good stuff too. And that was actually an economics faculty member from Columbia, I think, or somewhere around there. Okay. Repeatedly building, iterating. I don't know if you guys have had this happen, but failure, right? Like experiment goes wrong. We do that all the time. I do that all the time. Okay, that didn't work. Namatad started after a year of failures, right? I had that conversation with the fire chief, and I didn't have something that it was even plausible to work for a year. Honestly, if you're going to the Ph.D. program, you're probably hitting something like that now, right? But being able to sustain that and go, okay, that didn't work. Next, try the next thing.
Awesome. Maybe one more question from either place, either the room or online. Went a little over.
Sorry.
No, it just means we don't have as much time for questions. I was thinking that, I mean, what about pitching, right? So, you've been in industry, you've been in academia, you've now been in the startup world, you've talked to venture capitalists, all that stuff. What what does your education teach you about pitching, or did you find anything valuable in it, and or where did you, maybe it was the School of Hard Knocks that you learned along the way? I'm not sure.
Yes and yes. I had a terrible pitch. Oh no, I'm not going to talk about that one.
You did things you can't talk.
For pitching, I think just being in front of people, knowing that you're with whatever you're doing, you are the smartest person in the room. Maybe not really, but in your area and whatever it is you're trying to get across, yeah, you're the smartest person in the room. Not hiding failures. I think that those failures just show you that you've rounded things out enough where investors will trust you more. And keep in mind that I have specifically avoided taking investment, and not for lack of offers. In fact, I got some people right now that really just want to buy Namatad, and nope, I don't want to do it, at least not yet. But I think that yeah, being able to say no too. Being able to say no. It's hard, you know, because they start flashing a bunch of money in front of you, and you're like, okay, no, I'm not quite done with this yet. Yeah, just know that you know it.
Okay, great. Thanks, Matt. Let's thank our speaker one more time.